All right, diving right in today. We're tackling Ceph, specifically getting the most out of it on those smaller Proxmox clusters.
Yeah, Ceph. It's a beast, but a powerful one,
And
right?
powerful, yeah. It can
Okay,
be a resource hog, though.
yeah.
But that's why we're here for this deep dive. We've got this excerpt. It's called Optimizing Ceph for Small Proxmox Clusters. And, well, let's just say it's full of tips and tricks.
We're gonna make that storage sing, even on a modest setup.
Exactly. First things first, we got to talk networking. And I'm serious here. This is key. This document, it's screaming, Ceph needs speed.
Ceph, it lives for speed. All that data replication, moving between nodes. Gotta have a fast network.
So dial-up is out then. What kind of speeds are we talking?
10 gigabit Ethernet. That's your starting point, minimum. But if you're feeling really adventurous, the document mentions InfiniBand.
Okay, serious speed. But hold on. They also talk about this full mesh setup for like a 3-node cluster. What's that all about?
Think of it like each node has its own dedicated lane to every other node. Direct connections, no slowdowns.
So each node has a personal express lane to every other node. Makes sense. Now, speaking of separation, they're big on keeping public and cluster traffic apart. Why is that so important?
You don't want, like, client requests getting in the way of Ceph's internal stuff, right? Keeps things smooth, plus add some security.
Okay, got the network coming. What about the storage itself? More storage, better performance, right? Or
Not so fast. It's not just about size. This document, it's all about a hybrid approach. Mix that SSD speed with some cost-effective HDDs.
And they specifically say, even on a small setup, gotta have enterprise SSDs for that journaling and metadata.
Journaling, it's got to be reliable. You want those enterprise SSDs with, power loss protection and all that jazz.
Okay, so mixing SSDs and HDDs. How does Ceph actually handle that?
BlueStore. It's Ceph's storage engine. It's designed to leverage those SSDs for something called write-ahead logging.
Write-ahead logging. Explain it like I'm 5.
Basically, BlueStore takes write requests, jots them down on those fast SSDs even before the data is fully written to the HDDs.
Yeah.
Speed boost.
So that's why those enterprise SSDs matter. Fast network, smart storage. Anything else we got to worry about?
Gotta feed the beast, right? Ceph loves RAM and CPU.
Ah, yes, the hardware. Some listeners might be on a tighter budget, but the document does lay down some minimum specs, right?
For RAM, they say 16 gigs per node. Absolute minimum. Ideally, you want 32 or more, especially with that mixed storage setup.
So give BlueStore plenty of room to work. And what about CPU? How much processing power do we need?
Multi-core is a must. 6 cores or more per node, ideally. That'll keep things smooth, especially when you've got multiple OSDs running.
So it's not just about cramming in as much storage as possible. Got to have the horsepower to make use of it.
Exactly. It's like having a powerful engine. Without it, all the fancy aerodynamics won't help you.
Right. Okay, so hardware is sorted. Now let's get strategic. Disk layout and caching. How do we make the most of our storage space?
The document talks about tiered storage, using separate OSDs for SSDs and HDDs, different levels of performance within the cluster.
Breakdown time. What's an OSD? And how does this tiering thing work?
OSD, that's Object Storage Daemon. Basically, it's a manager for each storage device. With tiering, you're setting up different lanes for your data.
So frequently used data, that gets the SSD fast lane. Less urgent stuff, that chills on the HDD lane.
Exactly, like a filing cabinet. Important stuff in the top drawer, less urgent things down below.
Clever. But how does Ceph know where each piece of data goes? Has a map or something?
CRUSH map. Ceph's internal GPS tells it where to store and replicate data. You can configure it. Say, hey, put this on SSDs, this on HDDs.
Customizable data flow. Nice. Now, what about SSD caching? Is that just about adding more storage?
Not at all. Think of it as a turbocharger for your HDDs. It grabs frequently used data, keeps a copy on the SSDs ready to go.
So even if the data lives on the HDDs, we still benefit from the SSD speed.
Right. It's all about balance. Getting that speed without needing all SSD storage.
Okay, a lot to think about. Fast network, storage setup, anything else before we move on?
They do mention some internal Ceph tweaks, things like OSMEX right size, OSTUP threads, fine-tuning how data is handled.
All right, starting to get a little technical for me. What's the takeaway for our listeners?
It's about fine-tuning, making sure your Ceph cluster is working in harmony with your hardware and your workload.
So setting up Ceph, it's not just set it and forget it.
Right.
What else do we need to be thinking about?
You got it. Testing and monitoring. Can't just assume everything's running smooth. It's like building a race car. You got to test it before you race it.
True. What's the testing strategy here?
They recommend Ceph OSD Bench. It's like putting your OSDs through their paces, see how they perform.
And for those who want to go all out, they mentioned third-party tools like FIO.
Yeah, FIO's like taking your Ceph cluster to a professional racetrack, really push it to its limits.
Sounds intense. But testing's only half the battle. We also need to keep an eye on things in real time.
Exactly. Ceph has a great dashboard, real-time monitoring, performance analytics. You can track latency, disk usage, all that good stuff.
It's like having X-ray vision into our Ceph cluster. And this is even more important in a smaller setup, right?
Especially important. In a small cluster, every node matters. Proactive monitoring helps you catch problems early.
We covered a lot in this first part. Fast network, hybrid storage, powerful RAM and CPU, and even some disk layout and caching. What's next?
We've built the engine, tested it out. Now we need to make sure it runs smoothly long term. So in part 2, we're diving into monitoring and maintenance, keeping that Ceph cluster humming.
Can't wait. But before we go, something to ponder. We've talked about making Ceph sing on a small Proxmox cluster. What's the most demanding application you trust to run on your setup? Think about it. We'll pick back up in part 2.
Welcome back. We're deep in the trenches, optimizing Ceph for those small Proxmox clusters.
I hope everyone's had some time to, dream big about what they might run on their newly optimized Ceph setup.
Some big ideas brewing out there, I bet.
But before we go full speed ahead, we got to revisit something crucial from part 1, proactive monitoring.
Can't just set it and forget it. Remember, in a small cluster, every node is critical.
Right, if one goes down, it's a much bigger deal than in those giant setups.
Exactly. So we need to be more than just casually checking the dashboard. We need alerts.
Alerts, okay.
Yeah.
Like, what kind of alerts should we be looking out for?
Well, first off, any Ceph health status changes. If it goes from health hawk to health warn or even worse, healther, that's a big deal. Got to know immediately.
Okay, no, ignoring warning signs. Anything else that needs a flashing red light?
Definitely OSD down events. If one of those goes down, part of your storage is gone. Data's inaccessible.
And I'm guessing those cryptic cluster warnings, those need attention too.
Absolutely. They can be early signs of, network issues, resource problems, all sorts of things. Catch them early.
So we're treating our Ceph cluster like a high-maintenance race car.
A high-performance machine, that's for sure. You got to stay on top of things.
Right. So we're monitoring like crazy, but what else can we do to keep things in tip-top shape?
Well, just like any machine, Ceph needs regular tune-ups. Keep that Ceph version up to date.
So it's not just about getting the latest features. It's about performance, stability, security, right?
Bug fixes, enhancements, security patches. You got to stay current. It's like basic computer hygiene.
And it ensures our Ceph cluster plays nicely with any new hardware or software we might add.
Exactly. Keeps everything running smooth. Now, beyond updates, the document also talks about scheduled maintenance windows.
I know some folks dread downtime, but sometimes it's necessary, right?
It's like going to the dentist. A little discomfort now can save you a lot of pain later.
So we're scheduling those maintenance windows. What kind of tasks are we doing during these time outs?
Log cleanup, for one. Ceph can generate a lot of logs. It's like an overflowing email inbox. Got to clear it out.
A little digital decluttering. What else is on the maintenance checklist?
Disk health checks are essential. Make sure those drives are healthy, no errors. It's like checking your car's engine for cracks.
And I imagine it's also a good time to review our Ceph configuration. Make sure it's still optimized.
Absolutely. Your needs might have changed since you first set things up. It's like making sure your car's tire pressure is still right.
So it's all about proactive care, monitoring, updates, maintenance. Not the most exciting part, but it's important.
It is. It's like taking care of a garden. You got to weed, water, prune.
Yeah.
Keeps it healthy and thriving.
And that applies to any Ceph cluster, big or small. Those good maintenance habits, they matter.
Absolutely. A well-maintained Ceph cluster is a happy Ceph cluster. And happy admins.
Speaking of happy, remember that question from part 1. Now that you've got these optimization strategies, what's the most demanding application you'd trust to run on your Ceph cluster?
I'm eager to hear what our listeners are thinking. But before we get to those exciting possibilities, let's let all this sink in. When we come back in part 3, we'll explore some real-world use cases and see just how much potential even a small, well-tuned Ceph cluster can have.
All right, welcome back to the deep dive. We've covered a lot of ground with Ceph, all the technical stuff, testing, monitoring. But now, what can we actually DO with all of this?
Time to put it all into practice. See what it can really handle.
Exactly. We talked about those demanding applications. I'm curious, what are our listeners thinking?
Well, one area where even a small Ceph cluster can really shine is virtualization. All those virtual machines running on Proxmox.
So even if, like, a Proxmox node goes down, those virtual machines, they can keep running, right? Thanks to Ceph?
That's right. It's like having a safety net. Data's always available, even if a server kicks the bucket. Plus, scaling up. Easy. Just add more nodes to the cluster.
Makes it a lot more accessible for, smaller organizations that might not have a huge budget.
Exactly. All those enterprise-level features without the enterprise-level price tag.
Okay, so virtualization, check. What other heavy lifting can we do with our Ceph cluster?
High-performance databases. The kind that need, super fast responses, no downtime.
So we could run, like a mission-critical database, even on a smaller setup.
It's definitely possible. Spread the data across multiple nodes, add some SSD caching, and Ceph can handle it.
And of course, that replication we talked about, that's a lifesaver for data protection, especially for something like a database.
Absolutely. Like having an insurance policy for your data. Make sure it's always safe and sound.
Okay, virtualization, databases. What other frontiers can we explore with a small, optimized Ceph cluster?
Well, with big data and machine learning becoming so popular, Ceph is a great solution for storing all those massive data sets.
So even if we're not, Google scale big data,
Right.
a smaller Ceph setup can still be useful.
For sure, it can grow with you. As your data needs expand, just add more storage to the cluster.
And it's flexible, right? Structured data, unstructured data, it can handle it all.
That's right. Ceph doesn't discriminate.
It's pretty amazing. All the things we could do with even a small Ceph cluster once it's optimized.
And let's not forget, it's open source. So it's a lot more cost effective than those, big proprietary systems.
Yeah, that's a big advantage, especially for organizations on a budget. Get all that power without breaking the bank.
It's a win-win.
Well, I think we've really explored the depths of Ceph optimization in this deep dive, all the technical details, testing, monitoring, and even some real-world use cases.
It's been a journey. Hopefully our listeners are feeling ready to get the most out of their Ceph clusters.
I hope so too. But before we wrap up, I want to leave everyone with one last thought. We've talked about the what and the how of optimizing Ceph, but the why is important too.
What do you mean?
It's about remembering the bigger picture.
Right.
Why are we doing all this? It's not just about, making our hardware sweat. It's about what that performance enables.
Right. It's about empowering users, supporting innovation, helping organizations do incredible things with their data, no matter how big or small they are.
Exactly. A well-optimized Ceph cluster, even a small one, it can really make a difference. So as you go out there and start working with Ceph, keep that in mind. Remember why you're doing it.
I love that. It's been a pleasure diving deep with you, and I can't wait to see what our listeners achieve with their supercharged Ceph clusters.
Thanks for joining us on the Deep Dive. Until next time, keep exploring, keep learning, and keep pushing the limits of what technology can do.